Continuing lesson 1 in module 5. Again, we're talking about right now, we're still using that concept of we're dropping a stone or a bowling ball or something from a roof 256 feet. Now, the difference of this is something we've been doing in the past is in the past, we've been working with constants and linear. And as we talked in the last video, this is gaining speed because of gravity. Okay, so it's not just multiplying by one number. And so we're kind of looking at this relationship, this idea of a function, the relationship between the number of seconds to the distance traveled in feet. Okay, so this is just really an extension of this video right here. And we've added some half seconds in. So it says in number 1 here, name 2 predictions you can make from this table. Okay, so this is, pay attention to this. There might be something like this in your homework if I remember correctly. What are we predicting? This is the information we're getting. What are we predicting? Don't overthink it. Let's look right here. After 2 seconds, how far has the stone fallen? Well, so I'm going to say after 2 seconds, the object, what happened to the object? Fell 20 or 64 feet, right? Or, I guess we don't know what's fallen, but I'm going to say the object fell 64 feet if we're still thinking of that video. Wants 2 though, so maybe we'll say after 3 seconds then, right? Don't overthink it. Think of this more as a reading a table. What does it mean? Okay. The object fell 144 feet. Okay. So again, it's not like we're multiplying, 1 times 16 and then 2 times 16. No, it doesn't work that way. Okay. The next one says, name a prediction that was going to require some more information. Well, what if I wanted to know how far I had traveled after 3.75 seconds? That's going to be halfway between the 3.5 and the 4. But remember, I can't just take half the distance between here because it's not that constant. It's not traveling by the same amount every time. So I can't say, oh, it's fallen 10 feet. That means halfway between would be 5 feet. Nope, gaining speed. So my prediction is going to be, or that my prediction that requires information is, what distance would the object have traveled or have fallen? Say have fallen. After 3.75 seconds. Where did the 3.75 came from? I was just picking a number that wasn't on a table. Okay. All right. Now, what is the average speed? What is the average speed of an object? I am, again, glad to see nothing has changed. Still struggling writing or drawing straight lines. Between 0 and 3 seconds. Okay. How does this compare to the average speed in the same calculated same interval in example 1? I'm not going to worry about that right now because I'm not sure that we did. I'm peeking here quick. Oh, yeah, okay. Okay, so if we're going from 0 to 3, what they're saying in example 1, and just reference it up here, way back in the last video, we said that it had a constant of 64. So it was traveling 64 feet every second. So we want to compare that to this one between 0 and 3. So we're going to take our distance traveled over this interval and then divide it by 3 seconds. So going back up to our table, well, there's no 0 on here. So let's think about this for a second. In 0 seconds, how far has the object fallen or fell or whatever? 0 feet, right? It hasn't done anything yet. So we're still at 0, 0. So if we're going from 0 to 3 right here, Remember, we're having half seconds here. We're going from 0 seconds to 3 seconds. That's 144 feet. So the distance traveled is 144. And we divide that by 3, and we get 48 feet per second. Okay, and just kind of talking about that compared to example 1. Remember, in example 1, it was falling at a constant speed of 64 feet per second. This one, though, remember, we're still hitting the same 256 feet, but it's starting off a lot slower. All right. So take a closer look at our data. So I'm going to go back up to that table a lot here. How many feet did the stone drop between 0 and 1 second? So sorry for scrolling here, but from, let me get rid of some of these lines here. Okay, so we're going from 0 to 1. 0 to 1, 16. 16 feet. That's how far the stone dropped. How about between 1 and 2 seconds? Well, how many feet? Now this one, and I might, since I have my little cheat sheet over here, not scroll back every time, but I want to show you where it's coming from. Okay, so we went from 0 to 1. Now I want to go from 1 to 2. So I'm going from 16 feet to 64 feet. So I'm just going to subtract them. I want to know how many, what's the difference there, right? 64 minus 16 is equal to 48 feet. Okay. And then it wants between 2 and 3 seconds. So again, I have my cheat sheet here, but if you went back up top and found the 2 second and the 3 second, and I'm going to take the difference. So my 3 second is 144 feet, and I'm going to subtract 64 feet. That was my 2 second drop, and that's a difference of 80 feet. So notice it fell 16 feet in the first, well, I guess we'll get there in a second. Fell 16 feet in the first second, and then it fell 48 feet in the next second, and then the next second it fell 80 feet. So if we're going now between 3 and 4 seconds, that's, if you look on that chart again, 256 feet minus 144 feet, and that's 112 feet. So you can see as each second goes by, we're falling faster. So compare the distances the stone dropped from one interval to the next. What do we notice? Well, again, it's increasing, right? Now, if we're looking at it, okay, what do we notice? Okay, I'm going to say this with this bad arrow here, right? Picking up speed. So we know it's not linear, but it's still a function. There's still a relationship between the number of seconds and the number of feet that have fallen. So if we're going to compare the distances the stone dropped from one time interval to the next, so if we are going to compare 48 to 16, so in our second interval of time, if we go 48 minus 16, that equals 32 feet. There's a difference of 32 feet. If we look from 80 feet to 48 feet, it's a difference of 32 feet. If we look for 112 to 80, guess what? 32 feet. Okay, so from each interval, okay, it's increasing by 32 feet. Okay, so I'm just going to say the difference, that means subtraction. The difference, I'm going to choose the correct word here. The difference is the same. Okay, and that comes into play way later on in math when you're figuring out what type of function it is. Right now, we're just introducing the concept function. But it's interesting that our speed increased each time, and that interval ended up increasing by 32 feet. It didn't just go, it didn't just go up by 32 each time, and that's important, okay? If 16 to 30, 64, 64 to 144, 144 to 256, it's not going up 32 each time, but the difference is going up 32 each time. All right, last one. is there a pattern to the data of the falling stones? Okay, is there a pattern? And that's kind of where this is coming from right here. Notice to go from 1 to 16, okay, we multiplied by 16. But to go from 2 to 64, we didn't multiply by 16. So it's not constant. We multiplied actually by 32. 2 times 32 is 64. To go from 3 to 44, we didn't multiply by 16 or 32. We multiplied by 48. And to go from 4 to 256, we actually multiplied by 64. Okay. Just stick with me here. So for this one right here, we did 1 times 16. This one was 2 times 32. This one is 3 times 48. Okay, and this one is 4 times 64. Again, just stick with me. I want to show you something that's going to come into play later. We know it's not linear, but it's still going to be a function, okay? This time, though, we're not going to have a variable that's to the first power. Okay, so I want to look at 32 right here, and I want to break 32 down into 2 times 16, right? And so this becomes 2 times 2 times 16. And I want to break 48 down here into 3 times 16. So if you did a calculator, don't worry about the y right now. I just want to show this to you. This one becomes 3 times 3 times 16. And if I broke 64 down here, that's actually 4 times 16. So this becomes 4 times 16. Okay, so if you look at this, 2 times 2 times 16. Well, 2 times 2 we can write as 2 squared times 16. 3 times 3? Well, that's 3 to the second power times 16. 4 times 4? Hey, guess what? That's 4 to the second power times 16. Well, what about this 1 down here? This is 1 times 16. Could I write this as 1 to the second power times 16? Well, 1 to the second power is 1 times 1. Yes, I could. Okay, so notice that we're taking whatever this number is. Okay, and again, just don't overthink this. Don't stress that you're like going to have to do a bunch of these problems. No. Think about the concept. We're trying to introduce the concept. We're trying to introduce the fact that we're not going to only work with linear numbers. Linear variables. We're taking whatever our time is. In this case, they're calling it t. And 1 to the second, 2 to the second, 3 to the second, 4 to the second. So we're going to say t to the second. And then we're noticing timesing them by 16. So is there a pattern? Yes, there is. It might just not be as obvious as we've been doing, but it's still something we're going to be able to figure out later on. Again, don't overthink any of this. Just remember that we're talking about a function here, and it's a rule. A function is a rule, way back to the first video, that assigns, this rule here assigns whatever you put in for your input here, it assigns an output. 1 to 16, 2 to 64, 3 to 40, 144, and 4 to 256.